Greetings and hello everyone. This is Dr. Ilangovan. I am a professor in the Department of Aerospace Engineering from SNSCT College of Technology, Coimbatore. This video is intended for the open elective students who are from the other department, other disciplines other than the aerospace department. Now they are in the third year and then they have chosen the open elective as basics of aeronautical engineering, and this is intended for them. We are talking about the fifth unit and then the aircraft instruments. This is in continuation with the previous video on equivalent airspeed. Now today we are in this video we are going to look at the true airspeed. Let's get started. The true airspeed is what we are going to talk about here, and then we see the panels where the speed is all indicated here. Uh, the speed, as you as has been explained in the previous thing, is been measured by a pitot tube. This pitot tube is fitted with a sensor called sensor, and then it is exposed to the airflow. It jets out of the surface of the aircraft, and as it moves above, when it gets exposed to the airflow, it can measure the total pressure, and that is how the whole thing is getting interpreted. Now, let us look at the various the construction of the pitot tube. The air enters here. There's a baffle plate to stop the dust, etc., from coming inside uh, the and then you have the pitot tube as it goes inside. There's a pressure chamber, and there is also a drain hole. You have a heater here in case the air has to be is too cold, etc. And then you can hear the heater can be made switched on and off. You have the static chamber and then the pressure chamber. What do we measure here? Airspeed indicator is there as being like the boron gauge. We have the airspeed indicator, the vertical speed indicator, and the altimeter. All three in one go, and then it finally connected to a static port. You have an alternate static sources also there, and in this, what we are going to learn is that the pitot pressure is equal to the static pressure plus the dynamic pressure. Okay, so this is how it is being exposed outside. What is true airspeed or TAS? In the previous video, I did not expand the TAS, but then I wanted to keep it for this video. TAS stands for the true airspeed. True airspeed is the actual speed of an aircraft relative to the air mass it is flying through. It represents the true velocity of the airplane, independent of the wind speed or the direction. So it is the velocity of the airplane. Okay, so TAS is the crucial factor for various flights calculations, including the time to that is to reach, etc., time en route, then the fuel consumption, the range, performance parameters. All these things are dependent on this. TS versus indicated airspeed, understanding the difference. Indicated airspeed is what the airspeed indicator displays based on the ram air pressure acting on the pitot tube. The true airspeed, however, considers the effects of air density on the indicated airspeed. As altitude increases, uh, air density decreases, leading to a difference between the TAS and the IAS. TAS is always greater than the IAS at higher altitudes. Conversely, at lower altitudes, the denser air causes the TAS and IAS to be or the true airspeed and the indicated airspeed to be closer in value. The true airspeed indicator is a pilot's friend. A true is a valuable tool for pilots to determine the true airspeed. It is a mechanical or electronic device that factors in pressure, altitude, and outside air temperature or OAT to calculate the true airspeed. Some true airspeed indicators are integrated into modern avionics system, while others are standalone instruments. By knowing the true airspeed, pilot can make informed decisions regarding the flight planning, performance calculation, and the overall situation awareness. The modern methods for determining the true airspeed is by using some valuable tools advanced in technology have led to the alternative methods for determining the true airspeed. One is the flight management system or the FMS, where you have the modern aircraft is always equipped with the FMS, which can calculate the true airspeed on various sensor inputs and aerodynamic data. The GPS-based true airspeed calculation, some GPS receivers can calculate true airspeed by factoring in wind speed and direction derived from satellite data. TAS plays a vital role in the meticulous process of flight planning, estimating the en route time. We have already discussed about this. The accurate TAS calculation allows the pilot to determine the estimated time it will take to reach the destination. Fuel planning, TAS is factored into the fuel consumption calculations, ensuring pilots have sufficient fuel for the planned flight duration. Calculating the range, knowing the TAS enables the pilot to estimate the maximum distance at an aircraft can travel with a specific fuel load. So this is something very much remembers the previous case study that we have posted earlier, where the pilot fails to gauge the fuel that is left, and then the air crash is imminent there. Importance of TAS for safe flight operations. Uh, Maintaining control characteristics. TAS helps pilots understand how the aircraft will handle at different airspeeds, enabling them to maintain proper control throughout the flight. Preventing stalls by knowing the adjusted stalling speed based on TAS, pilots can prevent the aircraft from entering a dangerous stall situation. Staying with the airspeed limits, TS awareness allows the pilot to adhere to the and to the specified airspeed limits, a number of limitations of their flight, preventing them from exceeding the critical airspeed. The last slide talks about the ground speed, which is calculated by the true airspeed minus the headwind at the ground level, and that's the ground speed. Okay, so we will continue with this lectures again on another video. Thank you for listening. Have a nice day.